In this lesson, we're going to talk about data normalization. Now, data normalization means that you're going to optimize the storage and use of your data within a given database. Most database designers are going to try to use data normalization to increase the optimization of their databases. Now, there are many different data normalizations that we can use, known as the first normal form, the second normal form, the third normal form, the fourth normal form, and the fifth normal form, also abbreviated as 1NF, 2NF, 3NF, 4NF, and 5NF. The first normal form is going to eliminate any redundant information in individual tables. This means that every set of related data is going to be stored in a dedicated table, and each of those tables is going to have information assigned with a primary key so we can reference it back to other tables. For example, if I'm going to store all of my customers and then their instructors, I would have two tables, one for customers and one for instructors. Then, when you want to assign the instructor to that student, you're not going to add the instructor's name into the student table. Instead, you're going to reference the instructor number. That way, we don't have to write the same name like Jason Dion 100 different times. We write it once and we refer to it based on the ID that is inside of that instructor table. The second normal form, or 2NF, is going to have all the related information that's applicable to multiple tables to have their own table, and that'll be associated through the use of a foreign key. We'll talk more about primary keys versus foreign keys later on in the course. The third normal form, or 3NF, is going to eliminate fields that do not depend on a given key. This way, you can eliminate some of that data and normalize it even further. The fourth normal form means that the data has to have a relationship that is in BCNF, or Boyce-Codd normal form, and has no multi-valued dependencies in them. Most of the time, you're not going to see data inside of 4NF in most of the databases you're going to be working with. The fifth normal form, or 5NF, has all of the same characteristics as the fourth normal form, and it ensures there are no joint dependencies inside of that database. Now, when it comes to the Data Plus exam, no one is going to ask you about first normal form, second normal form, third normal form, fourth normal form, or fifth normal form in terms of being able to identify them based on a given example. I just wanted to introduce this concept to you because you may come across it in the field when you're working as a data analyst. Most of the time, you're going to find data in either the first, second, or third normal form when you're working out in the field. Let me show you an example of a database table that is in a not normalized form. You'll notice here I have the student ID, the first name, the last name, and then the amount of payments made by students across a 3-payment plan, amount 1, amount 2, and amount 3. Now, notice here that we have 3 different students, student 1000, 1001, and 1002, and we have 3 payments from each of them. Now, why is this not normalized? Well, it's not normalized because we have all of those tuition payments listed in the rows with those student names. Instead, we should have a student table, which would be the first normal form, and this would have student ID, first name, and last name. Then we can have a second table, which would be the second normal form, which would have the pay transaction number, the student ID number, and the tuition amount. Now, when I want to put that information together and run a report, I can say, show me all of the times that Jason, who is student 1000, has made a payment, and it will come back and give me all of the different payments that Jason has done. Now, why would we want to normalize our payment data like this? Well, this allows us to use dedicated transaction numbers inside of our pay table in that second normalized form. This allows us to have a reference number that we can look at to verify the payments have been made. Now again, the idea here is that we have a relationship between these two tables. We have the students in the student table in our first normalized form and their student IDs. Then we can use those student IDs to link back to the different payments made by a student. Now, the key here though is that the primary key that we're using in the student table is the student ID. But when we get to the payments table, we're not using student ID as the primary key. We're using the transaction number. And that transaction number is unique each time because some students have multiple payments. Notice that Jason, who is student 1000, has made 3 different payments. One for 1500, another for 1500, and a third for 1500. This tells us a student has made 3 payments and we have 3 unique transaction IDs, and those are the primary key, not the student ID, because a single student can make multiple payments, so it can't be the primary ID inside of this pay table. And that's how it helps us to normalize this data by referencing data in another table instead of adding that data into the initial table. This makes our databases smaller and more optimized for us to be able to get the data out of those databases in a much quicker and easier way. And that is the goal of data normalization here, by establishing the relationships between the different data in the first form and the second form to be able to have the data that we need when we run our reports.